Trigonometry, Chapter 5, Trigonometric Identities, Section 2, Verifying Trigonometric Identities, Video 5, Verifying an Identity, Example 4. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. Just a reminder, this series of videos is not connected from video to video, except for the first video. This is just a sequence of examples. Let's verify the identity. Cosine of alpha over secant of alpha plus sine of alpha over cosecant of alpha equals secant squared alpha minus tangent squared alpha. Now, if I were trying to decide which side is the chunkier side, which one is the more complicated side, I would probably start with the left and then try to transform it to the right. Or try to transform the left and the right into two equal things. We're actually going to end up doing the latter. All right, so let's start, and I'm going to attempt to do this in the same organizational manner that I showed in the intermediate video by citing my moves and organizing my work well. So let's start with, if I can have a pen, please. Pen, thank you. Let's start with cosine alpha over secant alpha plus sine alpha over cosecant alpha. Now, what can I do to this? Well, algebraically, I could add fractions and get a common denominator and add fractions. Trigonometrically, I could turn everything into sines and cosines. Why don't we go with the trigonometric approach? I could get a common denominator, but look at the right side of the equation. The right side of the equation is not a fraction. So I don't know if combining this into one giant fraction is the correct move or a efficient move. So instead, let's take care of the secants and cosecants by using reciprocal identities. Now, here's where you can streamline. What you should be thinking about cosecant over secant is that this becomes cosecant times 1 over secant, but that becomes cosine times cosine, which of course is just cosine squared. I want you to get to the point where you are efficient enough to think that process and write the result. So we're going to go ahead and write cosine squared for this guy because the reciprocal of secant is cosine times the cosine that was in the numerator. Similarly, what would the second fraction transform into? Well, the reciprocal of cosecant is sine, and there's already a sine, so we would get sine times sine, which is sine squared. Now, both of these were reciprocal identities, so I'm going to put reciprocal identities for short. I could even just put RI. I would know what that means in this context. Oh, wait a minute. That's a Pythagorean identity now. This is equal to 1. Pythagorean identity. At this point, could I turn the 1 into the right side of the identity? I could, but this is a perfect example of where you've made the left side as simple as you can. Let's see if we can make the right side match, and it won't take very long because secant squared of alpha minus tangent squared of alpha is also equal to 1 by a Pythagorean identity. So we have successfully shown that the left side, that was supposed to be a highlight, we have successfully shown that the left side is equal to 1, and we've shown that the right side is equal to 1. And since we've shown that the left and the right are equal to each other, this verification is over.